Welcome to the deep dive. Today, our mission is pretty ambitious. We're trying to pin down the timeline for when truly powerful AI, think large model intelligence, can actually run locally, right on the device in your pocket.
Yeah, and look at the sources. There's actually a surprising convergence. Most projections seem to land, around 10 to 12 years out.
So we're talking maybe 2035, 2037.
Exactly. That seems to be the window.
It feels a bit like history repeating, doesn't it?
Right.
Mainframes to smartphones needed Moore's law for density, Kumi's law for efficiency. AI is doing that same shrink, but maybe faster, and starting with software.
That's right. It's really striking how much of the heavy lifting, initially at least, comes from just smarter software techniques. The core idea is still train large, then compress.
Okay, train large, compress, makes sense. You get the robustness first.
Precisely. You need that solid foundation before you put the model on a diet, so to speak.
But how do you actually shrink these massive things without, breaking them? If you cut precision down by, say, 75%, doesn't that impact accuracy badly?
That's the million-dollar question, right? And the main tools engineers are using are things like quantization and knowledge distillation.
Okay, quantization?
Yeah. Think of it like swapping high-precision numbers, like 32-bit floats for much smaller ones, maybe 8-bit integers. So FP32 down to INT8.
Like making a huge image file smaller for the web.
Exactly like that. You lose some fine detail, maybe, but keep the essential information. And crucially, integer math is way faster on mobile chips. That gives you speed and size reduction.
Okay, makes sense. Speed and footprint. And distillation, you mentioned that too. Is that like the Cliff Notes version?
Pretty much. You use a huge, powerful teacher model to train a much smaller student model. The student just learns to copy the teacher's outputs.
So it gets the smarts without the bulk.
That's the idea. It inherits the knowledge without the massive architecture.
All right, so software tricks, quantization, distillation, they get us part of the way. But even a slimmed-down model needs horsepower, right? Especially without draining the battery instantly. What's happening on the hardware side?
Yeah, the hardware challenge is real. It's pushing the industry towards what we call heterogeneous computing.
Meaning not just the main processor.
Right. Moving beyond just the CPU and maybe the GPU to include specialized units. The big one here is the NPU, the neural processing unit.
Ah, the NPU. We hear about those a lot now.
Yep. It's custom built just for the kind of math neural networks love. Basically, tons of parallel calculations.
And the sources actually give a target number for 2025, right? Something like 100 TOPS.
Here's the benchmark, yeah. 100 trillion operations per second. Flagship mobile chips are aiming for that peak performance soon.
Peak performance. So what does 100 TOPS actually let us do now with foundational AI?
Well, that peak number lets current high-end chips run some of today's smaller foundational models pretty well. Maybe models in the, say, 7 billion parameter range.
Okay, but not the really big ones yet.
Not instantly and locally, no. For that future-proof, truly foundational AI running right on the device, we probably need something like 5 to 10 times that compute power, but sustained, not just peak.
Got it. Sustained power within the phone's limits. That's the gap hardware needs to close by, say, 2037.
That's the engineering mountain to climb.
Okay, let's jump ahead, assume we solve it. Foundational AI fits in our pocket. What's the biggest change that unlocks? The real game changer?
For me, it's the shift from cloud robotics to true embodied AI.
Explain that difference.
Yeah.
Cloud robotics. That's robots needing the internet.
Essentially, yes. They rely heavily on remote servers for their brains, and that comes with big problems. Latency, connection dropouts, privacy issues too.
Right, you can't have a robot reacting instantly to something unexpected if it has to phone home first.
Exactly. Embodied AI means the intelligence, the sophisticated world model, runs right there on the robot itself. Real-time processing.
And that allows for...
That unlocks genuine autonomy, especially for physical interaction with the world.
So we're talking moving beyond just driving around obstacles, like the different levels of autonomy.
Absolutely. Today's best mobile robots are maybe level 2, autonomous mobility, avoiding things. Local AI gets us towards level 4.
Level 4 being?
Complex, force-dependent tasks. Think using a key in a lock, turning a stiff doorknob, using tools properly. Things that require real-time feedback and adaptation.
Okay, that's a huge leap. And that's the stepping stone to level 5, the sort of all-purpose human-like robot.
That's the pathway, yeah. Local intelligence is key.
So wrapping this deep dive up, the key takeaway for you, listening seems clear. The next decade, maybe 12 years, is this intense phase of shrinking and speeding up foundational AI, getting it ready for our pockets.
Right. And maybe the final thought to leave you with is this. Once AI isn't just in the cloud, but physically present in millions of autonomous devices acting in our world, the whole security cauldron flips.
How so?
Well, it shifts from primarily protecting data centers to ensuring the physical safety, the security, the ethical alignment of these agents interacting directly and physically within our society. That's a whole new challenge.